We're going to talk about our last topic in complex numbers, which is complex conjugate. Conjugate is a word we'll see a lot this year, but this is our first time using it. And we're going to talk about what a complex conjugate is, and then the uses of complex conjugates, which is essentially division. So real quick, the definition is I want you to consider any complex number, and remember complex numbers are of the form a plus bi, and this is our real part over here, and this is our imaginary part, bi. And every complex number has a complex conjugate. So its complex conjugate, this number's complex conjugate, is just a minus bi. So very, very similar. The note here says the only change is the sign of the imaginary part. So a stays the same, the real part stays the same, but the plus bi becomes a negative bi, or vice versa. So here are three examples of complex conjugates. Our first one is 2 plus 4i, and its complex conjugate would just be 2 minus 4i. So changing the sign on the imaginary part. Negative 7 plus 2i, its complex conjugate would be negative 7 minus 2i. And finally, 3 minus 3i, its complex conjugate would be 3 plus 3i, changing that sign. So finding conjugates is actually pretty simple. You just change that sign on the imaginary part. But there are two uses that are super important in our math class. So the first is this. The first use says that multiplying conjugates, so multiplying one number by its conjugate, produces a real number that has no imaginary part. So think about this again. This means that multiplying two complex numbers, we end up with a real number that doesn't have I in it. Pretty special. So we're going to do an example here. We've got 2 plus 4i and 2 minus 4i, just like we had above. And we're going to multiply these out and see what we get. We should get a real number. So I'll start with distributing. I'll do this one by distributing. We'll do some more later with the box method. But 2 times 2 is 4. And 2 times minus 4i is minus 8i. And then we'll distribute on the other side our 4i and our 4i. 4i times 2 is plus 8i. And 4i times negative 4i is minus 16i squared. So we've got, we're starting to move. And now we just want to simplify this side. So the first thing I want to recognize, I'll underline it in red, is that this term is going to go to 0. Negative 8i plus 8i goes to 0. So we're essentially left with 4. This goes to 0. 4 minus 16i squared. This again simplifies out. And the next thing we can simplify is we've got our I squared, which we can get rid of. We know that I squared is just 4 minus 16 times, and I squared is equal to negative 1. And 4 plus 16 leaves us with 20, positive 20. Notice that at this step, when these i's cancel and this I squared becomes negative 1, we are left with no I term, no imaginary part. Super, super nice. All right, so why is this useful? Why would we ever want to do this? And the reason is division. So here we've got a division example. It says to divide by a complex number. So when we're taking a number and dividing it by something complex, dividing it by I, for example, the way we do this is by multiplying both the numerator and the denominator by the complex conjugate. All right, what does this mean? So we're going to do an example where we take the number 20 and we divide it by the complex number 1 plus 2i. So while we start this, notice that in the description there, I say there's a numerator and a denominator. And the reason I use those terms is because it's easiest to do division by complex numbers if you rewrite it as a fraction. So 20 divided by 1 plus 2i. And what it says here is that if we want to do this division, we actually need to multiply the top and the bottom by the complex conjugate. So 1 plus 2i, the conjugate is 1 minus 2i. So I'm going to multiply the top and the bottom by that complex conjugate. And if I simplify this into one fraction, what I'm doing is essentially saying I want 20 times 1 minus 2i divided by 1 plus 2i times 1 minus 2i. And so the rest of this is going to be just simplifying this out. And notice that on the bottom here, we're in this situation where we're taking a complex number and multiplying it by its conjugate. What this does is it leaves the bottom, my denominator, as a real number. So our I value, our imaginary part, will only be in the numerator. So it's taking this fraction and moving the imaginary part, the I value, up into the numerator, which is going to give us a prettier answer, essentially. So let's do this out. We're going to start by doing 20 times 1 minus 2i. 20 times 1 is 20. 20 times minus 2i is minus 40i. And then to do this complex conjugate multiplication down here, I usually just kind of sneak out and do a quick box method. So we want 1 plus 2i times 1 minus 2i. And I'm going to go through and do these 4 boxes. 1 times 1, 2i times 1, negative 2i times 1, and this is negative 4i squared. Now notice, just like we had above, our 2 terms with I in it are going to cancel out. That's going to be super nice. And so to save myself a little time, when I rewrite this, I'm going to leave them out as well. So I'm going to kind of say these 2 are going to cancel. And what I'm left with over here is 1 minus 4i squared. So far we still have this complex number on the bottom, but remember, if I start to simplify this, we're going to have 20 minus 40i, and our denominator becomes 1. Think about what this is. This is going to be a negative 1. This will be 1 plus 4 on the bottom. Or actually, let's rewrite this just so you can see it a little better as 1 minus 4. Oh, technical difficulties. There we go. 4 times that I squared becomes negative 1. Then my last kind of major division step, I've got 20 minus 40i. So that numerator has stayed for a while. And this will be 1 plus 4, which gives me 5. So this is one way I could leave my answer. I'll get a lot of complex conjugate multiplication that this will be my stopping point. But notice that 5 divides both 20 and 40. So I'm actually going to simplify this into fractions and say this is 20 divided by 5, which is 4, minus 40 divided by 5, which is 8i. So I'm simplifying those fractions. And we've taken the number 20 and divided it by something complex and gotten a complex answer. All right, so I'm going to do a couple more examples of these in the next video just so you can see them, but that's a quick overview of our complex conjugates.